All right, so now we are going to talk about how to solve compound inequalities with and, better known mathematically as intersection or conjunction. And in this case, our solutions need to satisfy the criteria of both inequalities rather than just one or the other. But same deal is you kind of solve it the same way as you solve any other algebraic equation or inequality. We just have to graph the solution set as a conjunction of both solutions together. So we are going to take care of these guys. First one, 9 minus 12r is greater than or equal to negative 99. So again, kind of breezing through this, we're going to subtract that 9 from both sides. I'm going to end up with negative 12r is greater than or equal to negative 108. Now, again, reminder, I'm dividing by a negative, so that tells me I'm gonna have to flip this inequality around. So rather than greater than or equal to, it is going to end up being less than or equal to. So r is less than or equal to, and negative 108 divided by negative 12 is positive 9. R is less than or equal to positive 9. Now we take care of our other inequality, so we know this is an and situation. It's going to have to hit both criteria. Negative 2r minus 4 is less than negative 12. Two-step solution. We add the 4 to both sides of our inequality. Negative 2r is less than negative 12 plus 4 is negative 8. Be careful with your operations with integers here. Double check it as necessary. Both sides need to be divided by that negative 2 because it was multiplying the r. And again, that means I'm going to flip the sign of my, or the direction of my inequality rather. So as opposed to less than, it now becomes greater than. Negative 8 divided by negative 2 is positive 4. So r also needs to be greater than 4. I also have another way we can put these two answers together since it needs to be both of these things. It needs to be greater than 4 and less than or equal to negative 9. So this is kind of one that where our answer is in between these two solution sets. So r is bigger than 4. 4 is less than r, and r is smaller than or equal to 9. So let's talk about how this is graphed. When we're graphing this, and we kind of went over this earlier in our video. I know 4 is down here, 9 is up there. Again, doesn't need to be super accurate with where the little, where your scale is, but it's more important to make sure you're graphing this correctly. So what we're going to do is down on the bottom, I would demonstrate how I would graph each one individually. So if I'm graphing r is less than or equal to 9, I would have a closed circle at 9, and it would be going infinitely less than that 9. If I was graphing r is greater than 4, I would have an open circle at 4, and I'd be graphing infinitely in the greater than direction. But because these guys overlap and I need to satisfy both elements, it needs to be less than 4 and greater than 4 and less than 9. Only numbers in between 4 and 9 are going to work here. So when I'm graphing this solution, we're going to keep that open circle at 4, closed circle at 9, and all we need to do is connect the dots because it's only the numbers in between that work, because any number that is greater than 4 but also greater than 9 does not satisfy the fact that it needs to be less than 9, and vice versa in the lower direction. It needs to just be what's in the middle. So that is how you solve a conjunction inequality, which will sometimes be signified with the word and.